Good afternoon, everyone. Welcome to
You need to
54th.
unmute yourself. I can't hear you.
Hello, sir.
Yes. Yeah, all right.
Okay. Good afternoon, everyone. Welcome to 54th episode of Creative Online Talks. Nowadays, photography is really important. We can express so much with it and through it. The sky is full of mysterious. Everybody is curious to know what is behind it. Astrophotography reveals the details and learn about celestial objects and develop better theories about past, present, and future. Today's topic of creative talk is Introduction to Astrophotography. To present this, we have Mr. Satyakumar PM Sharma sir with us. Before going to start the program, I like to brief about Creative. Creative is a group of people who are very curious to know new knowledge and gain the knowledge. Creative. Cre means creativity, active means activeness. To be active, we need creativity. Sharing of knowledge increases our knowledge. Knowledge square is our tagline. Creative vision is to build constructive thinking and progress in various fields. We focus on non-textual, non-academic, non-syllabus topics. Every Saturday, we are organizing online talks through Zoom platform and live streaming in our YouTube channel around 3 to 4 p.m. every afternoon. So we invite resource persons who are masters in their field, and Creative is a platform for the resource person to share their views, discoveries, experiments, observations with interesting audience. I thank all the resource persons for sharing their knowledge and for their time. I welcome our resource person, Satya sir, and I welcome all the creative volunteers and the participants for the today's session. I call Panindra to introduce today's speaker. Panindra, unmute yourself.
Hello, good afternoon, everyone. I am Panindra, and I am also a part of Creative team. And now I'll be giving you a brief introduction about Satyakumar Sharma. He's an aerospace engineer by qualification, and he's the founder and the partner of Universal Immersive Media and Education. He has been astronomer for over 22 years and astrophotographer since the past 16 years. He gazes at the stars almost every clear night and captures the beauty of the universe. His photos are published in Amateur Astrophotography magazine, which is published internationally. He has written a book about astrophotography named Capturing Cosmic Light, a handbook of astrophotography, which is also available on Amazon. And he conducts trips and classes about the astrophotography. And he is also a retailer of telescopes and provides one-on-one consulting for individuals and institutions who wants to purchase a photography. And he has a very good experience in astrophotography. And today he'll be talking us about the introduction of astrophotography. And sir, over to you. Welcome for our creative team.
Thank you, Panindra. Sir, over to you.
Yeah, thank you so much. One request, participants, please mute yourselves because
everyone.
Yeah, thank you so much. Because it gets a little distracting when somebody makes a noise in the middle of the lecture. But if you have any questions, feel free to ask. Interrupt me in the middle of the talk itself, and feel free to ask. Questions are always welcome, and no question is a silly question. So feel free to ask anything you want. Related to this, and this one though, I am an amateur astronomer. I am an astrophotographer mainly, and my interests lie in capturing the beauty of the cosmos. The colorful objects that we have out there, not just the planets and the moon, but galaxies, nebulae, and other things that I'll show you now in my presentation. I am not an expert in black holes, so please don't ask me anything about black holes or anything related to cosmology. I will not be able to answer that. but you can ask me anything and everything related to astrophotography equipment, how I do my astrophotography, all the nitty-gritty details, and I will happily explain it to you. So let us begin. I hope I have sharing permissions. Yes. So
Yes, sir. Yes.
yeah, I'll just share my screen. Okay, and we shall begin. Right. So there. Okay, you all are able to now see my screen, right?
Yes, sir. Yes, sir.
The main this one called Introduction to Astrophotography, right?
Yes, sir.
All right. So if anybody is not able to see me change slides or anything, please let me know. We can work it out. See, for example, I'll start with this. I mean, how many of you have? I mean, I like to have an interactive session, so please reply to whatever I ask or whatever we try to interact with each other. How many of you have actually gone out and on a dark night in a village or something like that? Gauribidanur is a nice town, but if you go right outside Gauribidanur, probably even from the HN Science Center or something like that, you could probably get a very nice view of the night sky. Especially when it's not raining in the summer or something, you should be able to see a little bit of the Milky Way or something. How many of you have actually tried looking at the night sky?
We have tried looking at the night sky, sir. Most of
you, Panindra, I know you have a binocular you got from me. So,
yes,
yeah. Anybody else?
Actually muted, sir.
So they're actually
Shall I
replying in
unmute
the
them?
chat box, sir.
Oh, they're replying the chat box. Okay, I'll also have a look at the chat box. Can I? No. Anyway, it's all right. If you can unmute yourselves and reply, it is fine. Otherwise, if you're unable to unmute yourselves, well, you can answer in the last. You see, if I tell you right now that this photo that you see here, you're all able to see this red, gaseous structure all over the place, and there are a couple of bright stars and all that. Can anybody guess what this is? What this object is?
I think it's a nebula, sir.
Okay, that's that's a general answer. Anything specific you can talk about? I mean, you can tell me what it is.
Sir, shall I unmute them?
Yeah, you can.
Okay, 1 minute. Okay. If anybody knows answer, you can.
Yeah, it's a
unmute
horseshoe
and-
nebula.
Sir, Satya sir, just unmute yourself, sir. It's muted.
Hello, sir.
Yeah, unmuted myself. Right. So that's the horse
it,
head nebula. Somebody said it's a horseshoe nebula, but that was close enough. So yeah, this object, I mean, most of you may not realize, is 1,500 light years away from us. And this object was captured from the heart of Bangalore city by me in March 2020, just after the or just before the lockdown, in fact. Before the COVID lockdown happened, on the 4th and 5th nights, 2 nights I took to capture this object from my terrace in Sahakar Nagar of Bangalore. Now, this is the kind of magic, or rather, I should not be using this word loosely, but this is the kind of art you can create with astrophotography, and none of it is false. Whatever you see here, the objects, the stars, everything is real. It's actually out there in the sky, 1,500 light years away. Okay. Now, the Horsehead Nebula, this object, is actually located in what is known as the Orion's Belt. Most of you, I mean, or some of you who have actually started to do stargazing, even with binoculars, or even simply looking at constellations of the night sky, you might have seen 3 stars at about 45 degrees in a line, same brightness stars. In the winter, you can actually see it in the east. around 9 o'clock or something, if you look up, you can see 3 stars in a straight line. The third star in that is the brightest star seen in the thing. I'll just see if I can use a laser pointer or something. Yeah. So this star that you all see is that third star. And this object here entirely known as the, it's basically collectively known as the Horsehead Nebula, but the horse head is actually only this part. You can actually see the shape of the head of the horse. This is called the Flame Nebula because it looks like a flame coming out. It's actually a dark nebulous region. The nebula itself is actually the reddish part here. Okay, it's called an emission nebula because this is invisible to the naked eye as such. You need specialist equipment to detect that specific frequency of light. I think 656 nanometers, called the H alpha region, hydrogen alpha. It's an emission in that region. So this is what the Horsehead Nebula is. It's a beautiful thing, and this object was captured for a duration of about 5 hours 40 minutes over 2 nights. I'll come into this thing later. Okay, I just wanted to give an introduction. Why do I say this? Is because astrophotography is not like our daytime photography, where we just take our mobile camera and everybody glows, click, 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 hundreds of photos. It doesn't happen like, it's not like taking a selfie or a landscape image, or even with a normal DSLR taking a daytime image. It's not like that. Astrophotography requires things much, much more than, just taking a click, as we call it. So I'll go to the next slide. I'll come to this genre, this type of astrophotography a little later down the slides. First, we'll look at something very simple. Okay. This is the image of the Milky Way captured from the Himalayas. Okay. In a place called Spiti Valley. Spiti Valley is at an altitude of roughly around 12.5 to 13,000 feet above sea level in Himachal Pradesh. From Manali, it's about 110 kilometers and takes about 8 hours of off-roading, literally, to get there. So the foreground, you can see the Himalayan mountains, and the bright region there is actually what is called the Key Monastery. It's a Buddhist monastery in a place called Key, K-Y-E. In Spiti, and in the background you can see the Milky Way beautifully in the sky. Somebody is using a mouse or something and moving. Somebody has got some writing permission or something, I suppose, on the slide. Please don't do that.
One more option is there in upside. You can disable annotation.
Where is that?
The one bar is there, sir.
Annotate.
Just unmute, disable it, sir.
Disable it.
Click on more option is there.
Yeah. Mouse and razor. More. Disable annotation for others. Okay.
Yes, sir.
Right.
Done.
Okay. So, yeah, I removed that. Now, right. So where was I? The Milky Way. The Milky Way is visible beautifully here. I mean, even to your naked eyes, even without a photograph, the Milky Way looks very, very beautiful and imposing from Spiti Valley, because it is considered as one of the best skies in the world, in fact. There is very little light pollution and, nothing to ruin the beauty of the night sky as such over there. And that's why many astrophotographers go to Spiti Valley in the first place, to capture the beauty of the sky. When I visited this place, I used multiple kinds of equipment, which you will see in the following slide. This is the simplest kind of astrophotography that you can do, basically. It's called wide field astrophotography. You just need a DSLR camera on a tripod to start with. You don't need any complicated equipment, just a DSLR camera with what is called a wide angle lens. I don't know how many of you have actually done any photography here. would be nice to know. You will probably have a raise your hand kind of a feature or something like that over there, and you should be able to, or you can put it in the chat box. How many of you have actually used a DSLR and a tripod and all that? You can actually use something as simple as that to capture something as beautiful as this. So this is a blend of two images. It's not a single image. One image was captured for the foreground to capture the mountains and the key monastery and other things, whereas the background image of the Milky Way was taken separately, and then both were blended in. Both were captured from the same location. Okay, so this is basically called wide field astrophotography. Very simple. You can do this. All you need is a DSLR and tripod, and if you don't own one, you can rent one from places like Toehold or some other companies which allow you to take a camera on hire. Okay, so even a most basic DSLR, you can do this kind of work. All right, so
can you show the two different pictures that you captured?
Sorry?
You said you captured one picture for the foreground, another picture for the background.
Oh, that's not possible. I mean, I have it somewhere else in the file, so I won't be able to show that. How do I change the slide? Right. So going to the next slide. Right. See, this is one step ahead from DSLR and a tripod. You see here, I'm using the pointer. This is my DSLR. This is a nice wide angle lens. This is the tripod. You can use the DSLR on the tripod to take a photo like that, or you can also use something called a sky tracker. This by itself is called the Sky Guider Pro. It's a brand name. Basically what it does is, as you have seen, objects, even the sun, the moon and everything, rise in the east and set in the west. To capture high contrast, clear, detailed images of the night sky, you need to actually take long exposures. If you take it only on a DSLR and a tripod, the Earth's rotation will cause the stars to become lines, called a trailing. So if it's if whatever I say is too technical for some of you, please let me know. I can probably try to dilute it down for you. It's called trailing. So to counter that kind of a trailing, you use a simple device called a tracker, which is aligned to the pole star. Okay, we'll just take it as pole star for the sake of saying it, but it's a point in the sky near the pole star called the celestial pole. This device, which has a motor built in over here, if you see the laser pointer, this area has a motor built in, and you see this black hole here. Yeah, there is this tiny telescope inside that with certain markings which allow me to align to the north celestial pole. So it goes like that, and it looks at the pole star. There is a ball and socket mounting unit here where I can mount the camera and point the camera to wherever in the sky I want to. But this thing will still be pointed at the North Pole. When I switch it on, it will track from east to west. Thereby, I can capture the Milky Way. So this is a very simple device available for about 46,000 rupees. So only this device, the tripod and the camera and all are extras. The camera itself cost me about, I think, 60 something. The lens cost me about 35. The tripod cost me about 5,000. So basically, you're looking at a setup which is over 1.2 lakhs or something like that. So this kind of a simple equipment will fit into your laptop bag or something, and you can carry it to high altitude places and all that, and you can capture the beauty of the sky. Now, yeah, this is me, and I'm setting up the, the camera to the sky itself. Yeah, this is a posing shot, obviously. I did the same thing at night, but capturing me in the night is a little difficult, a little bit dark, so I had to pose like this. But this is essentially what we do to align the setup. Okay, so this is another, this image itself was published internationally in the Amateur Astrophotography magazine as one of its cover page. last year or the year before. I think last year only, because I captured it on August 9th, 2021. And this was published last year or this year sometime early. This is a more complicated system. I'll come to it later. Basically, it's fully computer controlled. The mounting system. It's basically like the previous thing. It has a tracking motor and everything, like, you know, like this. But it's much bigger. Just this part here, what I'm showing in the laser pointer, that itself weighs about 10 or 12 kilograms. So, and this is called a counterweight. It weighs about 5.5 kg. So you can imagine how heavy the setup is going to be. It's fully computer controlled through the laptop, and it will move to, it will point the telescope. This is the white part is the telescope. The red part is a very dedicated astronomy camera. I'll explain later. It will point the setup to the whatever object I want to, and I can capture long exposures like this. In fact, this setup on this night was used to capture this. This is called the Andromeda Galaxy, about 2 million light years away from us. The image itself is about 100 and how many minutes? Some over nearly 2.5 hours worth of data was used to capture this image of the galaxy. This galaxy is a sister galaxy of our own Milky Way galaxy. It also has, you can see the satellite galaxies of the Andromeda galaxy have been captured. This is 1 and this is 2. This is the main galaxy itself. You have some beautiful, colorful stars here and there everywhere. This was captured from Spiti Valley, because from Bangalore, it's very difficult to capture certain objects. You need to go to very dark places, and you know, you need to have low dust, low moisture, and you know, it has to be dry weather. And it's very nice. It's easier to do it from a dark place than from a city like Bangalore, which has a lot of light pollution here and there. So everywhere, in fact. So this is the Andromeda Galaxy. But now let us rewind. All this is fine. I've just shown you Andromeda Galaxy, the telescope, the tracker, wide field imaging, and so a lot of things that, you know, that's happened. But we need to understand the basics of what actually the equipment required for astrophotography is. Initially itself, I had told you all that it's not just about taking a click, like a mobile phone, right? So let us, you know, go back to a little bit of history, just a little bit, because I like to talk about history. The telescope was invented by apparently a Dutch spectacle maker called Hans Lippershey. The story goes that, you know, his kids were playing in his workshop with spectacle lenses, and they happened to see a church spire or something like that close by, when they brought two lenses in front of each other. Galileo did not invent the telescope. Please don't go telling this to anybody, because that's the most common answer I get. All of you are muted, so I'm just going right into it. Otherwise, I would have asked you who invented the telescope, and some of them would have definitely replied Galileo Galilei. So Galileo did not invent the telescope. The story is that Hans Lippershey took it to his king, or the commander of the army or something, who in his town, and the commander dismisses him, saying that, you know, I will not fund you. He asked for funds because he said this will have military applications. You can see the masts of the sailing ships much before they are visible to your naked eye. You can see it with the telescope. They were in a seaside town. So anyway, he gets dismissed, and the telescope lands up in a local fair, or jatra as we call it. So Galileo's friend, who is visiting, looks at this, comes to Galileo, tells him, and Galileo immediately knows its implications, makes one and uses it for the night sky to view it. But those telescopes were very basic. They were single lenses. They were not polished really well, and extremely basic, something that you can find on Amazon for about, let's say, 1,000 rupees today. Those kind of telescopes. Real telescopes cost a lot of money now, because technology has improved. Glass types are there, different types of glass are being used to correct for certain errors and other things. Just like how, you get wildlife camera lenses. You can get it for 6, 7 lakhs, 8 lakhs sometimes. Similarly, telescopes are also equally costly. Not as costly as a camera lens, perhaps, but some of them are. So anyway, there are different types of telescopes: refractor, reflector, and compound telescopes, also known as Cassegrain telescopes or catadioptric telescopes. Refractors have lenses, one lens in toy telescopes, or a combination of lenses in decent telescopes. Combination of lenses are used, let's say at the very basic, one glass made out of crown glass, one glass made out of flint glass. They're either stuck together or spaced using an airspace by precise calculation. And this corrects for false colors, or otherwise known as chromatic aberration. So I won't get too much deep into it. It'll become too technical and all of you will get bored, literally. So that's the kind of a telescope. And there is something called reflector telescopes. Most modern professional telescopes are reflector telescopes. Most of you might know about James Webb Space Telescope. That's also a reflector telescope. You might have seen that golden color shiny thing. That's a combination of mirrors. Many mirrors are used to make a single mirror, to work as a single mirror, because the telescope had to be folded and sent in a rocket into space. So, and it had to unfold itself and assemble itself and then focus itself on stars, all sorts of technical magic happening millions of kilometers away from us. But at the very basic, it will have a concave mirror, something called a parabolic or a hyperbolic surface, which is precision polished and coated with either silver or gold in case of James Webb, depending on the frequency that you want to observe in. So silver, it's coated with silver as well as aluminium. Most commercial telescopes are coated with aluminium. Even I had a couple of telescopes which were aluminium coated. I mean, almost all of them are coated with aluminium anyway. So this kind of a telescope, light falls on it, converges to a point, and an absolutely flat mirror called an optically flat mirror deviates the light. As you can see here in the image number 2, here it falls here on the blue color thing. It's coated with aluminum in the front. Light falls there first, then gets reflected back. In the middle, there is one flat mirror at 45 degrees, and it goes to the eyepiece and your eye or a camera or whatever it may be. Okay. So the third type is a combination of the first two, where there is something called a corrector lens. There is a mirror for converging the light, whatever, and the light bounces back in front a little bit twice, and then goes through a hole, in fact, in the main mirror and to your eye. So that's called a compound telescope, catadioptric telescope, or commonly Cassegrain telescope. Okay, so right. This will be too technical, so I'll just graze through this thing. Basically, for astrophotography, you need something called an apochromatic doublet or a triplet. Point number C and point number D. At the very basic, you need point number C, which I used to have, and point number D. Apochromatic means, basically, I mentioned in the previous slide that there will be a refractor telescope will have 2 lenses at the very least, good ones, out of which one of the lenses will be made out of something called a low dispersion glass, where basically if you take a thick glass, it actually acts like a prism. If you shine a light, it will split it into its constituents, the Vibgya, or violet, indigo, blue, green, yellow, orange, and red. Now, a lens also does that. Basically, if you focus it, it will, something called dispersion happens, where not all frequencies of white light focus at a single point. Rather, there is a slight difference in the focus points. where the violet focuses at a different point, and the other end red focuses at a different point. Now this creates a trouble when you take photos. Your stars, Naveen, can please mute yourself. Stars will look multiple colors. It shouldn't. It should look its. Therefore, you need something correction, which is done an apochromatic doublet or a triplet. Doublet means 2, triplet. So they use glasses with low dispersion. So therefore, you will have proper colors that are supposed to be there and not those which are not supposed to be there. So that's how it is. And similarly, I mentioned already a reflector telescope. So it converges light rays from infinity to a single point, because the mirror is not a concave. Actually, it's a parabolic mirror at the very least, or a hyperbolic sometimes. Very cheap reflector telescope will have spherical mirrors, which are not very nice. Sorry, I'll just drink some water. I'm sorry, the lecture will be a little technical. It is inevitable. So I already mentioned that there is an optically flat mirror used to deviate light perpendicular to the optical axis. Andre, at 45 degrees, light will fall on it and it will go 90 degrees that way. So a focuser means a device like, some of you might have used a microscope. It will have 2 knobs. You have to rotate them to get a clear picture. So that is what is a focuser. And an eyepiece. For viewing objects, you have something called an eyepiece. For photography, you don't use the eyepiece. You replace the eyepiece with a camera. Okay. And that's how it is. I'll skip this bit. It'll be too technical. Now, if you want to do astrophotography, let's say, for example, you want to capture something as simple as the moon. Okay. You have a webcam in your house. You can still do it with a basic telescope. You get something called a webcam adapter. You can remove the lens of the webcam and attach this adapter. It is over here. You see this gray color thing. Yeah, one side will attach itself to the web camera, which is visible on the bottom right here. If you remove the lens, it will attach there. The other end, the wider end, will go into the focusing assembly of the telescope. So then all you have to do is connect the web camera to the laptop, and you can get an image on the screen, and you can take videos or a still photo or other things. Similarly, there are adapters to attach a point and shoot camera as seen here. There are adapters available to attach a DSLR to the telescope, like this ring over here. So these are the things available. See, truly speaking, 1 hour is absolutely insufficient to talk about astrophotography. I have to go a couple of days, in fact, to be truthful. Each day will have to be dedicated to each subject, like a telescope or a mounting system or something like that. So I'm trying to rush here a little bit. Please bear with me. If you have questions, you can ask, you can email me, you can WhatsApp me, or whatever it is, and I'll be happy to reply. Okay, now telescopes are telescopes, but what will you put them on, right? So you need a mounting system which is very, very stable, extremely stable, in fact, to carry the weight of the telescope. Anybody who has studied mechanical engineering, strength of materials, would know that any material has its properties, material properties, and therefore things like steel beams, maybe some other screws, fasteners, other things are designed for a particular, let's say something called before they yield or they break or something like that. It is designed for a certain purpose. Similarly, telescope mounting systems are also like that only, exactly. On the right side, you'll see a very cheap photographic tripod available on a site like an Amazon or something. For 1,000 rupees, or probably even 300, 500 rupees, you'll get something as cheap as that, which can probably carry the weight of a mobile phone. Even that, it will probably shake. On the left, you will see over here is called a fully computer controlled equatorial mounting system for telescopes. It can carry a payload of 18 kgs. In the center, you will find something that can carry 50 kgs and will cost you an arm, a leg, a kidney, and a liver probably. Roughly, even without the counterweight, it is about 18-20 lakhs. So I'll come into that. We'll go in depth now. So as I was saying, you need a very stable tripod or a mounting system for telescopes. Otherwise, it becomes very sad to use. Any magnification you put on the telescope, you try to put your eye there, the whole image goes disco dancing all over the place. You'll get frustrated. That is why I tell people, don't buy telescopes on Amazon. 1,000 rupees, 2,000 rupees, you get these plastic nonsensical things, and people think that's a telescope and they buy it. And after buying that toy, they'll come to us and say, sir, how do I use it? Now, what do I say? I'll have to break my hand on the wall. I can't even tell that to them. So that's the thing. I'm not but I'm actually telling the truth as to, how beginners can easily get scammed. In astronomy, there is a saying, there is no cheap and best. If it is cheap, then the quality is also cheap. If the price is costly, then the quality is also equally good. But then, of course, people will probably, if you're gullible, then probably people will sell you a 5,000 rupees toy telescope for 50,000 rupees also. That's also possible. So just be careful. Talk to an experienced person, visit an astronomy club or something like that before you make your decision. For example, Panindra wanted to buy a binocular. He contacted me saying that, sir, which one is best? So I suggested this or this according to your budget. You can see what not with what not, equipment. So that's how the conversation goes. Anyway, here you will see on the right side EQ6 and HEQ5 mounts from Skywatcher. So Skywatcher is a brand. Don't worry about the brand. Here you can see the weight of the item itself before the tripod. The black part, that's 10 kgs, and the white one is 16 kgs. I mean, you have to actually hold it in your hands, and it's so heavy before you set it up and all. So you need to be really determined to actually set it up and things. Anyway, when it comes to visually, as in with your eye, observing objects in the sky, your eye cannot see color. That I'll give you guarantee. You cannot see color at all. Objects will be visible like, a grain of rice or probably a little pearl or something like that in black and white, very faint in the black of space when you look through the eyepiece. Only experienced people will know what I'm talking about. You need to really do it to believe it. Galaxies which are 35 million light years away will be visible as just a pencil smudge mark when you look through the eye. But it still makes you happy that you're actually looking at something that far away. For visually observing, you just need a very simple mounting system called a altitude azimuth. Means mount which can go up and down movement and left-right movement. Okay, as seen in the top image here. See, left, right, up, down. That's all. And it can be put on a tripod and the telescope can be mounted. It's easy to use. It won't have any motorized systems or anything like that. And you can just view the moon, the other objects and everything. But time to time, you need to manually adjust because, the Earth's rotation will still be there. So it will move out of the field and you need to adjust it. It's all right. The next kind of mount is called an equatorial mount. Now here, as I showed you in one of the very first images where I was sitting and, aligning something little portable tracker thing. So that is also called as an equatorial mount. Here, one rotation axis is parallel to the Earth's axis. The Earth's axis is actually not pointing to the pole star. Pole star is in the general direction. It's actually pointing to something called the North Celestial Pole, which is about 1.5 full moon distance from the pole star. If you can imagine, 1.5 full moon distance from the pole star. So the pole star is also not stationary. It actually goes around this blank point in the sky called the North Celestial Pole. Here, the axis of rotation is pointing to that, which means it is parallel to the Earth's axis, which means that any object that goes around the Earth's axis, like the sun, moon, or planets, or whatever stars they may be, will also go around that axis, which is pointing to the north celestial pole. So that kind of a mounting system, which is basically here also, that, these two mounting systems that I showed you, and the one I showed you in that photograph, all of them are the same. They point towards that north celestial pole, and they have motors in them, stepper motors, and some computer boards which communicate with the laptop, and very super precise movements take place, and they can follow the object through the night. So this kind of a mounting system is required if you want to do astrophotography. Here, these are the different kinds of equatorial mounts, but from professional observatories. This here on the right side, the telescope which is pointed vertically, is in America. This, the one in the bottom, is also somewhere else in the world. This is actually, the one on the top left is actually in India, about 150 kilometers from Bangalore, in a place called Kavalur, towards Chennai. The telescope is actually a compound telescope, or a Cassegrain telescope. It has a mirror 2.34 meters in diameter, and is on a something called a horseshoe, and it's a mix of horseshoe and an English yoke or something like that. It was built by the Tatas, and it's still operational, and it is used for scientific purposes. Scientists, or professional astronomers as we call them, astrophysicists, do not take beautiful photos of the night sky. It's people like me and you and everybody else who are interested in that. These people actually attach scientific instruments called spectrographs and several other instruments to the telescope, to one of its ends, to the top end or the bottom end, to measure certain things about stars or galaxies or other bodies in the universe, to study our universe better. So I just showed it to you because it's huge. I mean, it's massive when you go there. Kavalur itself, I think it's open every Saturday from 2 p.m. for the public. You can visit. They'll probably show it to you. Okay, so I was talking about payloads. Payload capacity. You cannot buy 1,000 rupees tripod and then put a $10,000 telescope on it and expect it to hold the weight. It cannot. So that's the same with telescope mounting systems. Top one over here, where the laser pointer is pointing, it has a capability of only about 2 to 3 kgs. The one on the right here, 3 to 4 kgs, maximum 4 kgs. Over here, this one has a payload of 6 kgs, this one 9.5 kgs, this one around 12 kgs, and the one that I have is about 18 kgs, and it goes higher and higher. The capacity, payload capacity of a telescope mount is important because stability, please mute yourself, Dhanwin. It's very important to take good photographs. I know, I keep repeating that, it will be too technical. Unfortunately, I cannot avoid it. The higher the payload capacity, the costlier it will be. It will be made really well. Something like here, what I have written: Astrophysics Mark 1, Losmandy, Takahashi, Paramount, all these will cost you a ton of money. I mean, 15-20 lakhs easily by the time you get into India. Something like this HEQ5, where the laser is pointing, it's about 1.5 lakh rupees. And the other ones, basic ones, are absolutely useless. So I might as well not talk about them. They are not meant for astrophotography anyway, the small ones. So yeah, that's what I was telling about. These are the premium and mounting systems. Okay, I'll skip those things. I don't need to go that deep. Cameras are some of the most important things in astrophotography. You can use a DSLR from Canon or Nikon with the lenses removed. You can remove the lens. There's a button there, and you can remove the lens. You can put an adapter, like the ring adapter I showed you earlier, and attach it to a telescope, which has a computerized tracking system. You can also get yourself a dedicated astronomical camera like what I have. I also have. Neither of these two though. These two are also dedicated astronomical cameras, bottom left and bottom right. These cameras basically have something called a cooling system in them. When you take long exposures of deep sky objects like galaxies or nebulas and other things, each click, okay, each click is about 2 to 5 minutes long. That creates a lot of electronic noise on the camera sensor, electronic sensor. Therefore, it is better if you physically cool the sensor down to several degrees below normal temperature. Let us say, for example, the normal temperature in the night is 25 degrees today. My astronomy camera can cool the sensor to minus 25 degrees. Means 50 degrees cooling capacity it has. It will go from plus 25 to 0, 0 to minus 25. Okay, it takes a lot of current for that. It takes about 5 amps or 3 amps or something like that. But it does that. So I have the advantage of having a noise-free image almost. So, and these cameras will cost you quite a bit. Nowadays, of course, cheaper astronomy cameras are available for about 80,000, 1 lakh rupees or something like that. They look like that left bottom image, red in color. I mean, the one I used for Andromeda Galaxy is like that. That camera cost about, it was borrowed, it's not mine, about 80,000, 85,000 rupees. This I won't cover, it will be too technical for you all. This also I won't cover. Basically, these are all camera companies and other things. So this also I won't cover, but this I'll talk about briefly. You see, the first image that I captured of the Horsehead Nebula was captured using something called a special filter. Filters are glass pieces which are coated with certain chemicals which allow certain frequencies to pass through but reject certain other frequencies. Rejection of frequencies is usually the light polluting frequencies like sodium, mercury, LED. All these frequencies are measured and the coatings are done on that piece of glass such that it will reflect it out, as in it won't allow it to pass through the glass, and only the good frequencies like red, green, blue, maybe, or H alpha and other frequencies are allowed to reach the sensor, and therefore you get an image even from a city. So these filters on the right here, red, green, blue is there. This is called infrared, or there are, for example, the one on the bottom here, it says O3, means ionized oxygen. That frequency it allows some 450 or something nanometers. I don't remember, 400 something. So these filters are very crucial. Each filter will cost you about, let's say, 12 to 14,000 rupees. And they will allow you to take some good color photos using a DSLR. Yeah. Now, this one is, now I'll come to the beauty part. This is an image of the moon, part of the moon, not the entire moon, obviously. Some craters are visible here and all that. This was captured several years ago. I don't even remember when, probably 10 years ago. I don't remember. Using a very long focal length telescope called a Schmidt-Cassegrain telescope, and something called a planetary camera. Imaging planets and the moon and other things is done through high-speed video. Video frames are combined together to create a still frame. Okay, so that is how planetary imaging is done. The clicks are very fast. You can take about frame rate of 60 frames per second. You can take 60 frames to even up to things like 220 frames per second. Why it is done? It's a different thing altogether. There is a reason why it is done. Obviously, it's a scientific reason to counter the atmospheric turbulence of Earth, so that, you know, the image doesn't shake around. This is not required for galaxies and nebulae and other things. This image was captured using a dedicated astronomy camera that I have from C.V. Raman Nagar in Bangalore. HAL, heavily light polluted. About 5.5 hours of data using hydrogen alpha and oxygen filters. over in a single night. About 5.5 hours of data was used, and this image was used by on the cover photo of Dr. Shailaja's book Akashadalli Enide Ekide. This was also a published image. This object is again in the near the Orion constellation, in a different constellation, but again thousands of light years away from us. This is called the Rosette Nebula. It's supposed to look like a rose. So this is one of the images. This is called the Monkey Head Nebula. Don't ask me from which angle it looks like the head of a monkey. It was captured on the following night after capturing the Horse Head Nebula. This also I took 2 nights to capture from Bangalore city, Sahakar Nagar. This is one of the telescopes that I have. The telescope is only this part. This is the mounting system, if you can see the laser. I can remove this telescope, put some other telescope on it, etc. This is a location. In the background, you can see, hundreds of thousands of stars and some nebula here and all that you can see. This is a location about 70 kilometers from Bangalore, near Kanakpura. From Gauribidnur also, you should be able to see similar sites, I would assume, if the light pollution is not very high. Yeah, so I go to such kind of dark locations and capture the beauty of the cosmos. This is from the same place. This is on the ground. This is on the terrace. 2 different telescopes. This image has, you can see this is the dedicated astronomy camera that I have. And here you can see a lot of wires and everything coming. It comes to the laptop. So it's all for computer control of the mounting system, the camera, and all sorts of other technical jiggery pokery that I have around. So basically in 1 hour, this is what I could probably cover. 55 minutes I have taken to talk about this. It's very, very difficult to talk about astrophotography in an hour, in fact, in a few days also. Astrophotography is like swimming. You cannot learn it through correspondence. You have to jump into the water and, learn to swim. That's the best way. But one thing I will definitely tell you guys, everyone, if you're interested in astronomy, please don't throw your money away in cheap things. A good telescope will cost you at least 20,000 rupees. Anything below that is going to be a waste of money, of time, setting up, frustration, a lot of things. And please don't buy telescopes from Amazon. They're just a aggregator sort of a thing to somebody who wants to sell on it. And the seller is probably trying to make a quick buck out of you. So buy it from somebody who has been selling telescopes, who practices astronomy, or somebody who knows his stuff. That is important. Otherwise, you'll end up wasting your money. So anyway, that's it, I suppose. If you have questions, now you can ask. We have about 10-15 minutes max. So
there are some questions in the chat box.
There are questions in the chat box. Let me see. Okay. Tips to do. Okay. I'll start from the top. Unmute me audio. I have Horsehead Nebula in Orion. Okay. Somebody said, Ashish said Horsehead Nebula in Orion. That's brilliant. Oh, thank you, Padmaja madam. Okay. No, it is not a telescope thing, Dr. Padmaja. That was discussed recently in one of the groups. It is not a telescope, unfortunately. Very basic information given in simple language. Thank you, Ashish. Only one question is there here from Abhay Thomre. Tips to do photography with normal camera gear. You just need a tripod, a DSLR camera. You cannot use a normal point and shoot camera. And you need something called a remote shutter release and a wide angle lens, the kit lens as we call it, which is supplied with the camera itself when you purchase it. That is sufficient enough to do wide field astrophotography. You can capture the Milky Way. You need to set it at something called a raw format and take a 30-second exposure in the widest setting. In 18 millimeter, you have to set it, focus it to infinity, and then take a 30-second shot. That's all you need to do. And of course, high ISO, let's say 1600 or 3200 ISO, and you can take this one. Any other question?
Sir, usually mobile, there are some apps known as deep sky photography or something. They say that I've tested the app. Now they have the exposure of around up to, in some very nice phones, you can get an exposure of around 5 to 10 seconds too. In normal phone, you can get an exposure of 2 to 4 seconds. So can we use this and take multiple shots and do photography?
You see, first of all, the sensors in these phones are absolutely tiny. They call them 64 megapixel, but what is the pixel size of the sensor? It is going to be 1 micrometer or something, closer to that. For astrophotography, you need sensitivity in the sensor. Low light sensitivity. Low light sensitivity is got by a larger pixel size, basically. Pixel should be able to have a capacity. Each pixel, consider it as a bucket. Okay, smaller the bucket, lesser the water it will hold, right? And the bigger the bucket, if you have a drum or something, it will take a lot of water, 50 liters of water probably, before it is full. Same thing happens with a pixel also. Light is considered as a particle. So the more number of particles you collect in each bucket, the better your image is going to be. So that's the best way that I can explain. Camera pixel sensors are only small. In that, the part of the sensor called a pixel is absolutely tiny. Therefore, you cannot use it for astrophotography. If that could be done, some of the world's best astrophotographers would be belting out amazing astrophotos using just mobile phones. So that's not happening. You need dedicated cameras which are designed for astrophotography itself. Okay. Now, Aditya Srinivasan says, I'm a member of we have a 10-inch Dob and currently looking for Aditya, the problem with Dobsonians is a problem called field rotation. You see, I told you initially that you need to have one axis aligned to the north celestial pole, right? In a Dob, you cannot do that. So therefore, astrophotography is all but impossible. It's a major pain in the backside, because when you manually follow whatever object that you're doing, the object will be there in the field of view perhaps, but the orientation changes. Therefore, you cannot do deep sky astrophotography with a Dob. You can image the moon, maybe some planets also, some people try with a lot of difficulty. Okay, but otherwise Dobs are not very nice. So forget about taking a DSLR or a mirrorless. You can probably get a nice high-end webcam and get a webcam adapter to do lunar photography. That is probably the best one. Okay. I hope that answers the question. Hamid is asking, which are the nearby places around Bangalore with low bottle levels? Around Bangalore, low bottle levels are very difficult, Hamid. Even this background image that you see here, right? That was a bottle 3. Now it has become bottle 5. And that's in the border of Banirghata forest. So you know where the sky is going. I mean, it's really bad. The nearest bottle 2 sky I have 2 or bottle 3 sky I have been to is 150 kilometers near Madanapalli. Okay, so that you need to be going that far. Dhanvin says, you said we are able to capture the Milky Way galaxy, but how can we? It's very simple, Dhanvin. We are part of the Milky Way galaxy. We cannot capture the whole Milky Way galaxy like I captured the Andromeda galaxy. What you see in the background here, even in this image, you will see a part of the Milky Way galaxy that, the density of stars that you see, like a band, that is one of the arms of the Milky Way galaxy. Okay. So depending on which direction you see, the thick one, like the one I showed in the very beginning with the key monastery, you're looking at the core of the Milky Way, towards the core of the Milky Way rather, not even at the core, but towards the core of the Milky Way galaxy. You're looking at part of this one. Like for example, if you're in a house, you can see the wardrobe in the room, you can see a chair in the room, you can see the walls or the plug sockets. That is how it is. You are in the house, you are seeing some part of the house. That is how it is. You cannot capture the whole thing, obviously. Okay. After Hubble telescope, why it takes 30 years to construct James Webb? Yeah, right. You see, first of all, the notion of a telescope we read in school, that's not how a telescope is. Something like the James Webb Space Telescope, which images in near infrared or infrared regions and all that, these are purpose-built billion-dollar telescopes, 10 billion or more cost. So they have to be sent to a specific point in space. The kind of engineering that goes into not just creating the telescope, designing the optics, let's say, for all the mirrors to precisely fit to each other, not even a millimeter up and down it can go. Okay. Or let's say its mounting system, the rocket engines which are there on it, the fuel tanks which will keep it in place, or any other thing, its pointing system will be different from a regular whatever I have here. So it's a hell lot of engineering and a ton of things that can go wrong. That is why it was delayed over and over and over again. And when the delays stopped and it was sent into space, it worked. That's it. It worked. Well, the Hubble Space Telescope, when it was launched, it was not working well. It produced very ugly looking stars because the main mirror of the telescope, Hubble Space Telescope, was astigmatic. And then they had to send astronauts in a space shuttle with a special lens called an anti-astigmat to counter the astigmatism. And they installed it on the Hubble Space Telescope 30 years ago. And, now, it has been working very well ever since. So that's the thing. So thank you for the last one. What is the best season for astrophotography, as few months have been bad weather? See, in Bangalore, I'll tell you, nowadays, clear season starts only in January first week, and it will probably go on until mid-March. That's it. Make the best you can out of it. New moon nights are best when the moon is not there for deep sky astrophotography. If you want to photograph the moon, photograph it when it is first quarter or third quarter or half. So that's the thing. I have seen a lot of your videos. Thank you. Who's this? Zahid. I have a Newtonian GSO which I purchased after seeing your review. That's I'm happy to know that, Zahid. How do I get to know the program of creative group? Achha, that's not this one, Ashish. Yeah. Any other questions?
Sir, can we have your contact details so that if we need any help from you in future, we can contact you?
Yeah, yes, of course. I will put my email ID down. You can email me whenever you feel like, and I'll definitely reply.
That will be better, actually. Yes.
So I have just put my email ID into the chat box. I think it went only to Dhanwin for some reason. Sorry, I have to put it to everyone. Sorry, SKP. Right. So everyone, that's my email ID. You can feel free to email me anytime you like to.
Thank you very much.
So, sir, apart from telescopes, can we use binoculars also to, start with the astrophotography?
No, you can't. No, you can't. I'll flat out refuse to say yes because you cannot.
What is the reason that we can't use it, sir?
One, the binocular is an awkward shape. Two, how will you mount a DSLR camera to a binocular by removing its eyepiece? You cannot. Three, mounting system for the binocular itself. How will you mount the binocular to something like a equatorial mount? You can't. And the binoculars have very basic lenses in them, nothing special. So no, you cannot use a binocular for astrophotography.
Okay, sir.
And if somebody claims as such, I saw it somewhere last year, he's lying right away. He's lying. So you cannot do astrophotography using binoculars.
Sir,
Okay.
how we
Yeah.
can build profession photography? Means what is the use of being a astrophotographer?
No use, absolutely useless. Because you do it, there are certain things, especially scientists, madam, we practice science for the sake of science. There is no outcome. I mean, there is no this one out of it other than personal satisfaction. Trust me, I have invested over 6 lakh rupees in my equipment and I didn't make 1 rupee out of it. So you do science for science sake. You do photography for photography's sake because you love the art. There is nothing you will gain out of it. There are probably only 3 or 4 astrophotographers all over the world, I would say, who actually make some money out of their astrophotography, and it's not their first job. They'll probably have a main job and this is something on the side. So yeah, you don't, there is no real this one out of it other than personal satisfaction in astrophotography or any other hobby for that matter. While hobbies are actually absolutely important because they take you away from the grind of daily life. They reduce your headaches, your tension, your stress levels, everything is reduced, especially when you do something like astronomy or astrophotography.
So, brief.
Sharmaji,
Yes.
Ramesh from KSTA.
Oh, sir, namaskara.
Namaskara. Your talk was so interesting and you spoke in a very simple language. I'm
Thank
sure
you,
students would have got a lot of information about astronomy, and some of them would certainly love to enjoy astronomy in the coming days.
I hope
Sharmaji,
so, sir.
we too have a series of talks for PU students. I'll be inviting you for one of the talks on astronomy.
I will be glad to, sir. I will be glad to. I'm happy that you were here. I did not know you were here in this group today.
I was there from the beginning of your talk. Sometimes I attend, sometimes because I will be in the office, I won't be able to attend. Today being a holiday, Srinath sir had sent me a link. I attended.
Okay. Right. Wonderful, sir. I'm very happy that you actually attended the.
Thank you, Ramesh ji, for attending.
Thanks, Srinath sir.
Satya sir, and tell me something about your book. You have published one book, right?
Yeah. It was published by Manipal University Press. It was done when I was.
If you have, you can show with you now.
I don't have it now because I'm in a little village in Pune district, I'll admit. It is in my Bangalore house and I've come to Pune and it is not with me. You can definitely find it on Amazon. I can, I don't know if I can post a link or something.
You can show in Google, right, sir? You can do it.
Yeah,
now.
I can do that. Hold on. I'll just send the link.
Sir, if you want to say something. Venkatesh sir, if you want to say something, please unmute and speak.
Sir, can I talk?
1 minute. Sir, I'm just posting the link in the chat box for everyone. This is the link to my book. Yes, Mr. Venkatesh, sir, please go ahead.
It is very nice to listen to you, sir. Actually, for the students, what I feel that if you highlight something about the star trail as well as the capturing of the Milky Way, the very second slide, what you have shown, Smithy Valley, how much, what is the lens you have used, what is the exposure you have done, and what is the, because it requires only simple equipment.
Yes, sir, he is also a photographer. He is also a photographer. You can.
I did astrophotography about Milky Way and star trails recently in Kutch, Gujarat. So that is the very beginning. At the beginning stage, the students can go with the star trails as well as this Milky Way photography. That is it will give a very interesting aspect. Let them stay instead of going for all the tracking equipment in the beginning.
Exactly.
With the wide angle lens as well as the simple exposure, okay, timing, how to stack the images. You just for 2 minutes. Thank you.
So star trails. Now everyone can remember that I said if you do not track the moving objects, it will create trails. Star trail photography is a beautiful way of starting astrophotography. All you need is a tripod and a DSLR. The DSLR comes supplied with what is called a kit lens. Okay, a kit lens will be marked 18 to 55 millimeter, 18-55. I think I might have mine over here. Yeah, this is called a kit lens. It will have a marking 18 to 55 on it. It's a very simple plasticky lens, which is given free with a DSLR usually, right? And once you attach it to a DSLR, like that, this is not a kit lens, this is some other lens. You can just mount it on a tripod and you get something called a remote shutter release. Okay, something like this. This is a digital shutter release. It has a programmable this one, and this end plugs into the DSLR. You can put in a number of exposures and the length of the exposure itself, and you can just on it. So basically, I'll just show you one image, which is a star trail image. Okay, I'll just share it there. Here, all part. Okay, let me see. Yeah, where is this? Yeah, this one. Right. So this image, right? Can you see this image, star trail image?
Yes, sir.
It is fully there. It is
No,
already
we can't see. It's not on the full screen.
You have to click on full screen. 1 second. Let me just reshare this one. Right. Okay. Now you can see this image, I suppose.
Yes.
This is called a star trail photography. Again, the foreground is the different exposure. The background is different. Foreground exposure is a single exposure. I think 90 seconds or something. That is 1.5 minutes or something I must have captured. Because you see on this, in the center, you can see a hill. And in that hill, you can see this yellow line going through. That is actually the headlight of a car that was going on the road there. So it created a trail over there when I took such a long exposure. The background is star trails captured for about 4 hours by my wife. And this was her first time. I'm quoting her because she's an absolute beginner. She has never, ever done astrophotography. I just told her how to do it. Put the tripod there, put the camera on it, point it to the north celestial pole. And in fact, she used a manual remote release. So every minute she went kachak, 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 kachak. Every 1 minute shots she took for about 4 hours. And all these shots were combined in a software called Star Trails. And this image was created. Later, the foreground was blended in using Adobe Photoshop. Okay, so that's how it was done. And yeah, this is the simplest form of astrophotography that you can do, where it shows the rotation of the Earth, basically. So what I said was that when I zoom in, you can see that the pole star is actually over here, and the center of the rotation, there is actually nothing there. You can't see a pole star there because the pole star is far away. If you look carefully, you can see this little streak here, all of you, that yellow thing, that's actually a meteor which entered Earth's atmosphere during that period. as well as over here, the blue streak that you see here, this is another meteor that entered during the period of capturing. So you can actually photograph a lot of things when you do star trail photography.
Request Girish also to give his observation. Girish, if you are there.
Thank you, Srinath. Sir, wonderful talk. I'm extremely happy to see pictures like this. So I hope the kids here and other enthusiasts, I have learned a lot from this one. And I agree with you that whatever Amazon sells is almost like crap. Sorry for using that word. I myself actually try to suggest them to keep away from it, even though people come up and say that, okay, my kid has actually identified one telescope which is only 4,000 rupees. What can we do with it? And some people have even come back later saying that, okay, we have already bought it. What are we going to see with that? So I hope your this talk clears many of those misconceptions. Thank you very much.
If anybody wants to purchase a telescope, I must tell you all that, I am also a retailer of telescopes. Telescopes do not make me any money. I do not run my business out of it because there is very little to no profit margin. But I only do it because I want to help people in making the right decision. Because when you buy a really bad quality instrument, it can make or break you. I mean, if you're having the patience to get along with this kind of a bad quality product, fine. But most of the time you cannot. Setting it up even to look at the moon is going to be a huge headache. So that's the only reason I actually sell telescopes, to help people make the right decisions. So let me know if anybody are interested.
Company.
Sorry?
Yeah, what company telescopes do you sell?
I sell multi companies, GSO, Celestron, Mead, Iopron, and I also, mainly my specialty is I customize, as in, because telescopes come with universal fittings, depending on the requirement of the person itself, I will suggest a GSO telescope or an Iopron mounting system or something like that, depending on the requirement, and some camera, that this, whatever it is.
Okay, that's great, sir. Do you have a site or somewhere where we can actually check out the models?
No, unfortunately, I do not have a site because my focus is on customization, basically. So it depends on, my distributors, what stock they have available and all that. Yeah.
Okay, great. So approximate range, can you tell, if you don't mind?
Oh, it depends. For astrophotography, you can get a telescope and a mounting system for excluding the camera for about 1.5 lakhs. It will last you easily 6 to 8 years.
So what is the range we can go with the telescope? You have just you told about the one telescope, what setup now, 1.5 lakhs. What is the range we can approach with the telescope?
Okay. I know what you mean by range. We don't use that terminology in astronomy as such, but if you were to talk about range or the capability of that telescope, you can capture images of galaxies which are, let's say, about 35 million light years away.
Good. Thank you. Thank you. Thank you.
Any more questions?
Sir, just for the beginner of astronomy, not for the astrophotography, we can buy like a Celestron Sky Master or something. Is that no? Sorry,
no, please don't. Please don't. I don't suggest AstroMaster to anybody. Please don't. It has a bad quality mirror in it. AstroMaster 130 actually does not have a good quality mirror in it. Again, another Amazon favorite for people. It has this beautiful orange and gray color thing. Please don't buy it. It's not a good quality.
One more question, sir. Are you doing any workshop on this astrophotography workshop or something you're going?
I actually had advertised, but since I did not get any people, maybe because of COVID or something, I have cancelled it. It was supposed to happen in another week's time in Spiti Valley.
Oh,
yeah.
It is for 1 week or 10 days, like?
Yeah, it will be for 8 days, 7 to 8 days.
7 to 8 days. Okay. I think it is usually between March and May. That is
Yes.
we'll do.
No,
Okay.
even now. In fact, Spiti Valley for them it is summer and clear season now.
Okay.
So it's kind of nice to go around this time.
Okay. So there you will concentrate what you thought today, or only.
Yeah, something like this. Star trail photography, wide field Milky Way photography, a little bit of deep sky photography.
Okay. Okay. Okay, sir. I'll be in touch with you. Thank you.
If you're interested, please message me privately. I can give you the details.
Okay. Thank you. I'll contact you.
All right. Okay. I think we can conclude now.
Yes, sir.
Yes.
I think. Any more questions? If not, we can conclude here.
I think we'll conclude
Sir,
now. I have some other thing to attend to.
Yes, sir. Yes, sir. We will. Thank you very much, sir, for your time and your knowledge for sharing with us. It's very pleasure to have you in Creative, sir. Thank you very much,
Thank you
sir.
so much.